Learn to make a fully working Battle Royale game you can play with friends using my Udemy course. Try for $13.99 using the link in the description. Hello, today we're going to be making something called a spectrum visualizer. And if you don't know what that is, here's what that is. And we're going to be making it in Unreal Engine, which basically means you could put this into a video game, or you could do whatever you want with this. But Unreal Engine is such a cool thing to make this in. And previously it was quite difficult to make these in Unreal Engine, but in 4.22 we got this new thing called the time synth component. And the time synth component does some really cool stuff, and I'm not going to go into detail, but one of the things that it does is spectral analysis. And that allows us to make this. So without further ado, let's go ahead and make a spectrum analyzer in C++. Okay guys, so once you have Unreal Engine 4.22 installed, very important you have that one. We're going to go to the Unreal Project browser, new project, C++, and then just click basic code. If you want, you can do like first person if you want to be able to run around the level, but I'm just going to go with basic code. And then we'll just go down here, and I'm just going to call this spectrum analyzer, and then just click create project. Alright, so let's do some real boring stuff and just get it out of the way. The first thing we need to do is actually enable time synth, and the way that Unreal Engine have packaged it is a plugin. So if you go to edit, plugins, in here somewhere there'll be one called time synth. So it's probably going to be under audio. If you click on audio, here it is here, time synth. So just go ahead and check this box. It says enabled, click yes, and then click on restart now. So to make sure that you're doing everything all right, if you come into Visual Studio and just double click on spectrumanalyzer.u project, it should now say time synth, and then it'll say enabled. Now Unreal Engine is made up of things called modules, and different bits of code are inside different modules, and there's actually a time synth module that we need to enable. So if we go into Spectrum Analyzer and open up our build file, we're simply just going to add the time synth module in here. So we have this private dependency module names thing, and if you literally just do this, just type time synth, you should now be good to go. So now the time synth module is going to be included, and we are able to use all of the time synth stuff in our project. So we're just going to get started straight away in our project. If you go to File, New C++ Class, you'll be able to make a actor. So we're just going to make an actor, and we're going to call this the spectral visualizer. And then just click on create class. If you get this box come up in Visual Studio, just click yes to all. It's simply just going to reload the files because we've added a new actor. So if you click yes to all, over here the actor should come up. And it hasn't. Oh wait, no, is that it there? No, that's not it. Here we go, spectral visualizer. And I don't know where the C++ file is. But anyways, for some reason it didn't come up there. But if you right click and go toggle header code file, it will come up. So this is our spectral visualizer actor. And all I'm going to do is I'm going to make a series of static meshes that will just bounce up and down to the music. So let's start off with the core of the actor, which is going to be this time synth component. So we're going to declare a time synth component. We're going to type u time synth component, and I'm just going to call it time synth component. And we're going to expose this in the editor by typing u property. And then if we type edit anywhere, we'll be able to see it inside of the editor. And we're also going to give it a category, and we'll just give that the category audio. So that's our time synth component done. The next thing that we need is we need some meshes that are going to bounce up and down to the music, those bars that you remember. And the way that I'm going to do this is I'm just going to make a T array. So in Unreal Engine, the array is called T array, and you need to declare the type that you're using. And in this case, I'm using the static mesh component. And I'm going to call this spectrum bars. So these are just simply the bars that represent a different frequency in the song. And we'll just do the exact same thing where we just give it a category. And that's all we need to do. And then the last thing we need to do is, I'm just going to literally copy and paste this. We need something called a time synth clip. So the time synth component will play a piece of audio, and the piece of audio is represented as a time synth clip. So we're just going to type in time synth clip here. One last thing that I'll do is I'll just declare something called the spectrum bar spacing. So this is the amount of spacing between each bar, and that'll just allow us to move the bars further away from each other if we want them to be. So this is the amount of spacing between each bar. And that is pretty much it. Oh, one last thing is we need the mesh to use. So this is going to be a U static mesh, and we're going to call this spectrum bar mesh. What this will allow us to do is use any mesh we want with our spectrum analyzer, so that not only can we have the bars that bounce up and down, we can have any mesh we want bouncing up and down. So we could use spheres, or we could use like pyramids, or we could get some really cool visuals going. So with that done, that's pretty much it. I'm also going to override one function here called post-edit-change-property. And what this does is this is a function that is called when we change a property on the actor. And I'm simply just using this because when we change the spectrum bar spacing, I want it to change on the fly. And when we change the spectrum bar spacing, this function is going to be called, and we can use that to then spread the bars out. I'm going to make a function as well called refresh, and refresh is simply just going to refresh the actor. So when we change the spectrum bar spacing, it's going to call this function, which will then like spread the bars out. And I think that's pretty much it. So at this point, we can start actually doing some of the logic for the actor inside of spectralvisualizer.cpp. So we'll start off inside of the constructor. The first thing we need to do is declare the amount of spacing. I'm going to say that I want 1 meter between each bar. So I need to say spectrum bar spacing equals 100. And that will do 100 centimeters of spacing between each bar. And then we can change that if we want later as well. Now we need to create the components. The time synth component is really easy to create. We can just do time synth component equals create default subobject. And if you've done any Unreal Engine before, you'll know that this is how you create a component. And the component we want to make is the time synth component. And then we simply just give it a name. And the name that we want to give it is just time synth component. And one other thing we need to do is we need to enable spectral analysis. So simply just do b enable spectral analysis equals true. If you don't do that, it will not do any spectral analysis and your bars will not do anything. We also need to include the time synth component header file. So if you just come up here and say include time synth component.h. And we also need to include the static mesh component while we're at it, so we may as well just do that now. To do that, you simply just do components / static mesh component.h. So to create the spectrum bars, we're simply going to just do a for loop. So we'll do for int32 I equals 1. We're just going to say that while I is less than or equal to 20, then increment I. So we're going to do a for loop that iterates 20 times, and each time that the for loop goes round, we're going to create a new spectrum bar. So the first thing to do is to tell the time synth component to analyze the frequency for the bar. So if we do frequencies to analyze dot add, so this is an array of frequencies to listen to, and we simply just want to do I times 50. So what we're doing here is we're telling the time synth component to look at frequencies 50 at a time. So I'll do 50, 100, 150, 200, 250, and so on. And each of our bars is going to listen to that particular frequency. So if there's a lot of low end in the song, if there's a lot of bass in the song, these first bars are going to be bouncing up a lot. And then the high frequencies will be the later bars, basically. Now I'm going to come up with a name for the spectrum bar. Because we're making 20 spectrum bars, we need to make a name for each spectrum bar that is unique. And the way that I'm going to do that is I'm going to say fstring spectrum bar name equals fstring printf, and I'm going to call it spectrum bar %d hz. And the reason I'm calling it that is because then it's going to say spectrum bar 50 hertz, spectrum bar 100 hertz, spectrum bar 150 hertz. So you'll be able to actually see this in the editor, and you'll be able to see which spectrum bar represents which hertz. So then we just do I times 50. So now we have a name for the spectrum bar, and we can go ahead and create it. So we're going to do use static mesh component spectrum bar equals create default subobject, and we just do the exact same thing that we did before. So static mesh component, and then we just give it the name of the spectrum bar, spectrum bar name, like that. And I think I need, have I done something wrong here? I need to put a bracket there. Okay, so at this point we need to then attach the spectrum bar. So we just do setup attachment. And I'm just going to attach it to the time synth component. And while we're at it, let's actually make the root component the time synth component. So the time synth component is the root of the actor, and then all of our spectrum bars are going to attach to the time synth component. So the next thing to do is spectrum bar set static mesh. So we're setting the mesh for the bar to be the spectrum bar mesh. And now what we need to do is we need to offset each bar. So the way that we're going to do that is we're going to say set relative location. And we're going to move the bars along the x-axis. So we'll do f vector. And then we simply do I times spectrum bar spacing, and then 0, 0. And so what that's going to do is each bar will be moved appropriately along a line. So we'll just have a big line of bars. And what you can actually do is you can make the bars appear in a circle like this. You could do tons of other cool stuff as well, but we're just doing a straight line just to make things nice and simple. And then lastly, you want to do spectrum bars dot add spectrum bar. So this spectrum bars array is just going to hold all of the spectrum bars inside of it. Next up, we're going to implement a bunch of functions. So you can just go ahead and go to post edit change property, right click on it, and then where is it? Quick actions and refactorings, and then just create a declaration of it. If you have Visual Assist, you can do that, create implementation to make the implementation as well. And we're going to do the same for the refresh function. Or if you're old school, you can just type all of that out yourself. So when we edit a property, we're simply just going to say super post edit change property. You have to always remember to call the super function, otherwise it will not change the property. Or you may run into some issues. And then after we do that, we're just going to simply refresh the spectral visualizer. And literally the only reason we're doing this is so that when we change the spacing on the spectrum bar, it will react and actually start moving the spectrum bars away from each other. Okay guys, so if you made it this far, we are getting pretty close to having a working spectral analyzer, not too much longer to go. So when we begin playing, I'm just going to call our refresh function because why not, just to be safe. And when we start playing the game, we want to take our time synth component and we want it to play a clip, and the clip to play is our time synth clip. And I'll show you how to make a time synth clip at the end of the video because it's a little bit tricky to make, but nothing too crazy. So yeah, we need to write our refresh function. The refresh function is literally just adjusting the spacing on the spectrum bar. So literally all this is going to do is it's just going to be another for loop. I'm literally just going to copy and paste this. Except this time we'll start at 0. And we're literally just going to say if spectrum bars is valid index. I like to just check that the index is valid just to be safe, because sometimes you might run into some issues with that. So make sure that the index is valid, and then at this point we can do use static mesh component spectrum bar equals spectrum bars at I, and then we just do spectrum bars, spectrum bar set static mesh. So this will also handle when we change the static mesh, we're gonna refresh that so that you can see that actually happen in the editor. So spectrum bar mesh, and then we're gonna say spectrum bar set relative location, and we're gonna set that to I plus 1 multiplied by the spectrum bar spacing. So we're literally just doing the same thing that we did before, basically, in the constructor. Let's see here, and then just do 0, 0. And that's pretty much it. So that's just going to refresh the bars. If we change anything, we just want those bars to react accordingly. Okay, so the last thing to do is actually make the bars bounce up and down. And this is surprisingly easy. We're just going to do this inside of tick. So inside of tick, what we're going to do is we're going to iterate over the spectral data in the song. So to do that, we're going to do auto spec data time synth component get spectral data. So the spectral data is literally just some data about the frequency and how the amplitude of that frequency. So if there's bass, how much bass is there? Or if there's a high piano note, how intense is that? What's the amplitude of that frequency? So now what we're going to do is we're going to do use static mesh component spectrum bar. So we need to get the spectrum bar for the frequency that we're looking at. And to figure out which frequency we're looking at, we just do spec data dot frequency hertz. Now, we're going to do something a little bit finicky here, but basically, to get the spectrum bar for this frequency, what we can just do is we can say spectrum bars at the frequency divided by 50 minus 1. And the reason that works is because we're looking at frequencies 50 at a time. So if we simply divide by 50, that will give us the index of the spectrum bar for that frequency. So at this point, we can now say the bar scale is going to be equal to the spectrum bar get component scale. So what we're going to do is we're going to make the Z scale of the bar change depending on the frequency. So we need to start by getting the scale of the bar, and then we're going to simply say bar scale dot Z is equal to 1 plus the spec data. And before we looked at the frequency of the spec data, now we're going to look at the magnitude. So we want to know how powerful was that frequency, basically. And just to make the bars not bounce up too intensely, we're going to set that to be divided by 5. Otherwise, the bars will just go like super crazy and they'll bounce way too high. So at this point, we're going to do spectrum bar set world scale. So now we're simply telling the bar to basically bounce up and down. We're setting the scale of the bar. And a way to make this look a lot nicer is to use an interp. Because the frequencies in a song change so rapidly, if we didn't interpolate it, it would look really weird. I might even throw in a video of that just to show you guys. It really doesn't look good. But if we interpolate, the bars are going to move really smoothly and they're going to look super nice. So we're going to use this interp function called vinterp2. And then we're going to say we want to interpolate from the current scale of the bar. So get component scale. And we want to interpolate to the bar scale that we've just come up with. And then we just say delta time. And then we're just going to say 5. 5 is a pretty good number. This is the speed at which we are interpolating. And that is literally it. I think we now have a working spectral visualizer. So I'm going to go ahead and debug. We'll jump into the editor and I'll make sure that this actually works. And if you were watching closely, you probably spotted that I'm an idiot and I didn't put a second brace there. But once you add that, it should now work. And I don't know what I was doing on this line, but we need to make sure that this works. And I think you want to do that. That should work. So make sure you have those brackets in the right place. Mine wasn't compiling, but if we try run the debugger now, I'm pretty sure it should work. Fingers crossed. So once you've found the music that you want to play, you will need the music as a WAV file, or a WAV file, whatever it's called. And you'll need to make sure that the bit resolution is set to 16-bit. So if you have an MP3 file, I would highly recommend just going to this audioconvert.com website. Here's the URL. And just drop the file in here. And then once you've done that, set it to 16-bit and then just click on Start Conversion and just download it as a WAV file. Because I think Unreal Engine only accepts WAV and it won't work with MP3. Okay, so once you have your favorite song as a WAV file, I have a song by Drake. I'm not going to play it in this video because Drake's crack team of lawyers are probably going to come sue me if I do. But just drag it in and right click somewhere and then go to, where is it? Sounds, time synth clip. And I'm just going to call this my time synth clip. And then open that up. And then under sounds, you want to add an element. Go down here and then select your song that you have. And then at this point, we're going to come down to fade out time. Or sorry, uncheck this box that says apply fade out. And then we also want to come down to where it says num bars. And I'm just going to set this to 500 so that it just plays for a really long time. And at that point, that should be all ready to go. So we'll go ahead and save. And let's check out our Spectrum visualizer in the engine. So we'll go to C++ classes. We're going to drag the spectral visualizer into the level. And at this point, we're going to select the My Time Synth clip. And for the spectrum bar mesh, I'm just going to use cubes. So if we search for cube, I've got show engine content checked as well. The editor cube should come up here, and I'm just going to click on that. And here are our bars. Now, they're not spaced very well, so I might change that to like 200. That didn't work. Okay, I might have wrote that function wrong. But anyways, we can fix that in a bit. It should work fine anyway. It's just that the bars are only spaced out 100 units. But if we hit play, it should play our song, and the bars should react accordingly. Check it out. How cool is that? Something so satisfying about seeing that. I'd love to see what you guys do with this. If you manage to put it into a game or something, that would be so cool. Like if you could make a gun that had like a camo with this on the side or something, that'd be awesome. But yeah, I hope you guys enjoyed. Let me know what you decide to make with this, and I'll see you guys in the next video. See you later.